Hi everyone, today we are going to be talking about trigonometric functions of angles again, but first a quick warm-up, so please pause the video and give it a try. Alright, so here this was just a recap of our special right triangle side lengths, which we are going to be using very, very heavily today and for the rest of the chapter. So remember, for 30, 60, 90, the side lengths are always 1, 2, root 3. 1 is the smallest number, so should be across from 30, which is the smallest angle. 2 is the biggest number, so it should be across from the biggest angle, which is 90. So 1, 2, and so the last leg must be root 3. Root 3 is always across from 60. Same thing here. Across from the 30 is 1, hypotenuse is 2. Across from 60 is root 3. Same thing here, it's just different orientations. You'll see why we're doing this as we go through the lesson. But across from the 30 is 1, the hypotenuse is 2, the across from 60 is root 3. For a 45, 45, 90 triangle, we have the ratio side legs 1, 1, root 2. So the hypotenuse is always root 2, and the two legs, which are the pieces touching your 90-degree angle, are both 1. So today we're going to be evaluating the trig functions of what I call a unit circle angle. We'll talk more about what a unit circle is later on in this lesson, but it's essentially the angles that we've been filling out on that blank circle. So it's when you have the 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on and so forth. So those angles are, I like to call them unit circle angles. And when we are working with one of those angles, we should be able to evaluate sine, cosine, and tangent without using a calculator. Now there's different approaches to this, but what we are going to do is an approach that simply uses special right triangles, which is something we already know how to use. So step 1 is we're going to draw the angle in standard position. Step 2, we're going to connect that angle to the closest x-axis with a perpendicular line, kind of like we did in the last lesson when we were working with a coordinate on the terminal side. We will also connect our angle to the closest x-axis to find the reference angle, which remember we call theta prime. Once we have our reference angle, this time we're actually going to need to figure out what that angle is. It's either going to be 30 degrees, 45 degrees, or 60 degrees, which means we've just created a special right triangle. So we're going to use that special right triangle, we're going to fill in the sides, and then we simply use SOHCAHTOA to help us evaluate. Now, as we're doing this, this is kind of a way you can make sure that your answers are correct. These are the signs, the SIGN signs, of the different functions in the different quadrants. So a really common mistake I see with these is maybe your answer should be negative, but it was positive. So there's a little mnemonic device that math teachers use to remember this. It's all students take calculus. A-S-T-C. All students take calculus through quadrant 1, 2, 3, and 4. So when you see A, it actually stands for all. All of your functions are positive in quadrant 1. Everything is positive. Now in quadrant 2, we have this S. That tells us that only sine is positive. Cosecant will also be positive because it's the reciprocal function, but we'll just be talking about sine today. So if sine is the only positive one, that means cosine and tangent must be negative. Now in quadrant 3, we have a T. That tells us which is positive, so that must be tangent. So tangent is positive, which means cosine and sine are negative. And we have all students take calculus, so in quadrant 4, C tells us that cosine should be positive, meaning sine and tangent are negative. So we kind of can use this to make sure that our answer has the correct sign and make sure our process was correct. All right, let's give one of these a try. So we want to find the sine of 120 degrees. Step 1 was to draw in the angle. So we know that this is 90 degrees. We know that this is 180 degrees. So we know that 120 is somewhere over here in quadrant 2. This is theta. So now I need to take this angle, and I'm just going to pick a point somewhere, and I'm going to connect it to the closest x-axis with a perpendicular line. So you can see that I just made a right triangle. Now this angle right here, this is my reference angle, right? Because it's the distance to the closest x-axis. So we're actually going to find what that value is. So we know that the angle is 120 and the closest x-axis at 180. The distance from 120 to 180 will be 60 degrees. So our reference angle is 60 degrees. So since I have a 60-degree angle here and a 90-degree angle, this makes a 30, 60, 90 triangle. So I know how to mark up the sides. Across from 30 is 1, hypotenuse is 2, the other leg is root 3. But we have to be careful about something. This is an xy axis, and I know that if I'm moving to the left on my x-axis, that's actually a negative value. So this value needs to be negative. This value is moving up, so it should be positive, and the hypotenuse will always be positive. So now I can use this angle. I'm not going to use 120, I'm going to use my reference angle, which is 60, and I'm going to evaluate sine. Sine is opposite over hypotenuse, so the sine of 120 degrees is root 3 over 2. The sine of 120 degrees is root 3 over 2. Now if we remember that all students take calculus, we see that sine should be positive in quadrant 2, so we can feel good about our answer there. But again, we're just doing opposite over hypotenuse, so it's just SOHCAHTOA once you've filled out your special right triangle. And that's it. We are done. All right, let's try this next problem together. Here we have the tangent of 330 degrees. So I know that this is 270 degrees, and I know this is 360 degrees, so that means that 330 degrees is going to be way over here in quadrant 4. This is theta. And that means that this is going to be our reference angle, and then we also need to connect our angle to the closest x-axis. We always drop to an x-axis. If you connect to a y-axis, you will get the wrong answer. So here's our right triangle. So now we need to figure out what this measurement actually is. So this is 330, and the distance between 330 and 360 is simply 30 degrees. So we can see that our reference angle is 30 degrees. So again, what do we have? A 30, 60, 90 triangle. So across from the 30 is a 1. The hypotenuse is 2. This is root 3. But again, be careful. On an xy axis, if we're going down, that value must be negative. So this value is negative 1. This value is positive, and the hypotenuse is always positive. Then if I'm doing tangent, so tangent of this angle, I know it's the tangent of 330, but we're actually going to do the tangent of our reference angle. Tangent is opposite over adjacent. So the tangent of 330 degrees is going to be negative 1 over root 3. We do need to rationalize. So the tangent of 330 degrees is negative root 3 over 3. And again, we can kind of check all students take calculus. So in quadrant 4, cosine is positive. Remember, this shows us what's positive. So that means tangent should be negative. So this would be a really good thing to check because, again, it's super common that people will label this, but they'll forget the negative. So this could help you remember, oh yeah, my answer needs to be negative because only cosine is positive in this quadrant. All right, now let's give this one a try. So we have the cosine of 5 pi over 4. So we need to first figure out where this is. We know this is pi, right? And we know this is a little bit more than pi. It's pi, 4 pi over 4, plus an extra slice. And we also know that 5 pi over 4 is less than 3 pi over 2, which would be 6 pi over 4. So that means that my angle is here in quadrant 3. So here's my angle. That's 5 pi over 4. So I'm going to connect my angle to the closest x-axis with a perpendicular line, giving me a right triangle. And then I'm going to find the reference angle. So if this is 5 pi over 4, and this is 4 pi over 4, right? Pi is just 4 pi over 4. I can see that the distance is pi over 4. Now remember, pi over 4, so that's my reference angle. And pi over 4 is just 45 degrees. So here we have a 45, 45, 90 triangle. So for 45, 45, 90, both legs are 1. We do 1, 1, root 2. But then I need to go back and look because this leg, because I'm going down, should be negative. And this leg should be negative because I'm going left. So if you're moving left, the value should be negative. If you're moving down, the value should be negative. The hypotenuse is always positive. So we have 1, 1, root 2, but both of these are negative. Now, if I'm doing the cosine of that angle, again, we will be using the reference angle. So cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So negative 1 over root 2. This, again, we will rationalize. So cosine of 5 pi over 4 is negative root 2 over 2. And as a double check, all students take calculus. This tells us that only tangent is positive in quadrant 4. So if only tangent is positive, that means cosine should be negative. All right, let's try another one together. Here we have the cosine of 60 degrees. So we know that 60 degrees is between 0 and 90 degrees, so it is in quadrant 1. Here's 60 degrees. So again, I'm going to connect it to my x-axis with a perpendicular line, and I'm going to find this reference angle. If it's in quadrant 1, the reference angle is the angle, so it's 60 degrees. So again, I have a 30, 60, 90 triangle. Here's the 30-degree angle, so across from that is 1. So we have 1, 2, root 3. And nothing is negative because I'm moving to the right, which is positive, and I'm moving up, which is positive. And here, we want to do our cosine function. And we know that cosine is adjacent over hypotenuse. So it's going to be 1 over 2. And we don't have to simplify or rationalize anything, so we are done. And again, all students take calculus. All of the functions are positive in quadrant 1. So it makes sense that our answer is positive. All right, so I have a few for you to try on your own, so pause the video and give this one a go. All right, so a few things to check. Make sure you have drawn in your angle correctly. It should be in quadrant 2. Our reference angle is 45 degrees, making it 45, 45, 90. So you mark up the sides of your triangle, and please make sure this side is negative. We don't use it, but we do want to watch out and make sure we have it a negative here. Sine is positive in quadrant 2, so it makes sense that our answer is positive. And sine is opposite over hypotenuse. All right, pause the video again and give this one a try. All right, check your work here. 300 degrees falls down in quadrant 4. Our reference angle is 60 degrees. Here's the sides of our 30, 60, 90. And please make sure this one is negative because we're going down. And cosine is adjacent over hypotenuse, so 1 over 2. And since we are in quadrant 4, cosine should be positive. All right, one last one for you to try on your own. So again, please pause the video. All right, go ahead and check. 7 pi over 6 is in quadrant 3. My reference angle, this distance, is pi over 6. So this is a 30, 60, 90. So this side length should be -1 because we're going down. This should be +2, and this should be -√3 because we are going to the left. So tangent is opposite over hypotenuse, or opposite over adjacent. So both are negative, which results in a positive answer, which makes sense because tangent is positive in quadrant 3. So you may have noticed that none of our examples have had angles that are actually on our x or y axis. All of the angles have been inside a quadrant. But what if they are between quadrants? Well, we call these quadrantal angles. So the quadrantal angles would be 0 degrees or 0 radians, 90 degrees, which is pi over 2 radians, 180 degrees or pi radians, 270 degrees, which is 3 pi over 2 radians, or of course 360 degrees and 2 pi radians. So again, these are called quadrantal angles. So for this, we can't really make a triangle because, well, there wouldn't be a width here and there wouldn't be a height here. So we have to have a different method for evaluating these. And for this, we're going to use what's called the unit circle. So a unit circle, by definition, is a circle with a radius of 1. It's super important that our circle has a radius of 1 if we're going to use this technique. If the radius is not 1, it is not a unit circle. Now you'll notice that you see some really familiar angles here. That's why I call these the unit circle angles. These are all the ones that we've been practicing and all of the ones that we've used in the examples today. So these I call the unit circle angles. So don't worry about all of these coordinates. These are the coordinates on the circle for these angles. Don't worry about these. What I'd like you to look at are the coordinates here, the coordinates of our quadrantal angles, which are really easy to define. Because if I have a circle that's centered at the origin and the radius is 1, well, this coordinate, I'm just going to the right one, so it will be 1, 0. This coordinate will be 0, 1. This coordinate will be -1, 0, and this coordinate will be 0, -1. Of course, if we're going diagonally, these values are no longer 1 and -1. This only works because I'm on a horizontal or vertical path. Now, we can use these coordinates to help us evaluate sine, cosine, and tangent of these angles. So the trick is on a unit circle, and again, this is only for unit circles. The coordinates tell us cosine and sine. The x value of the coordinate is going to be the cosine of our angle. So for example, the cosine of 0 degrees is equal to 1. The y value of our coordinate tells us the sine of the angle. So the sine of 0 degrees is 0. And the tangent of that angle, you do the y value divided by the x value. So 0 over 1 is 0. I do want to remind you that if I did 1 over 0, you cannot have 0 in the denominator, so that value would actually be undefined. So again, we're only going to use the coordinates of the unit circle for our quadrantal angles. And it goes in alphabetical order, right? The x value tells us cosine, and the y value tells us sine. And then we just have to remember for tangent, we do y over x, because tangent is actually equal to, tangent is sine over cosine. This is something that we haven't talked about. And if sine is the y value and cosine is the x value, we do y over x. But all you need to remember, cosine, sine, and then tangent is y over x. And we will only use it for these 4 angles. All right, so we're going to evaluate sine, cosine, and tangent of the angle pi over 2. So I'm going to draw in the angle in standard form. Here's pi over 2, right? So we have pi over 2. And we're going to pretend that it's a unit circle, okay, which means the radius is 1, and I'm going to write that coordinate. The coordinate here would be 0, 1, because I'm just going up 1. So we know that the cosine of that angle is the x value, the sine of the angle is the y value, and then we know that tangent is y over x. So that means that the sine of pi over 2 is 1. The cosine of pi over 2 is 0. And the tangent of pi over 2, if I do y over x, I have 1 divided by 0, which is undefined. We will come across these undefined values, and when we start graphing these functions, you'll see that tangent, because it has undefined values, will actually have vertical asymptotes. So we're going to see asymptotes again this chapter. But for tangent, it is not uncommon to have undefined values. Okay, let's try one more together. So here we're going to do sine, cosine, and tangent of 180 degrees, which we know is this angle. So again, since it's a quadrantal angle, I'm going to turn this into a unit circle, which has a length of 1, a radius of 1. So since I'm just going 1 unit to the left, this coordinate is negative 1, 0. Again, this is cosine, and this is sine. It's alphabetical. C comes before S, and X comes before Y. And then we also know that tangent of theta is going to be y over x. So that means that the cosine of 180 degrees is negative 1. The sine of 180 degrees is 0. And the tangent of 180 degrees, if you do y over x, 0 over 1, or negative 1 is 0. So it's okay for your numerator to be 0, it's just never okay for the denominator to be 0. All right, so I have 2 more U-tries for you, so pause the video and give this one a try. All right, go ahead and check. So we can see, let me add this in, 2 pi is just a full rotation, so we're back at the positive x-axis, so I'm moving 1 unit to the right. So my coordinate on a unit circle would be 1, 0. So this is cosine, this is sine, and if you do y over x, tangent is 0. And here is the last U-try, so one last time, please pause the video. All right, go ahead and check. Here's 270 degrees, and if we're going down 1 unit, the coordinate would be 0, negative 1. Here's cosine, here's sine, and y over x gives us a tangent that is undefined. All right, that is all for today's video. Thank you so much for watching.